So, what kind of trig are we doing tonight? Have you gotten to the unit circle yet? Okay. So what kind of stuff are you reviewing? Okay. You have some problems we can do? No. Right triangles. Okay, let me see if I know what you're referring to. Like this? What are they asking you? For the dimension of the hypotenuse? Or are they asking you for what are those angles? All right. Let's talk about this because we haven't talked about this yet. I'm going to look at our 30, 60, 90, which has those dimensions. Okay. Now, if I said to you that the sine, what is the sine of 30 equal to? Okay, very important. We take trig functions of angles to get ratios. Okay? You take inverse or arc, what does your class refer to it as? We take inverse trig functions of ratios to get angles. So if number 1 is true, number 2 is also always true. You with me? Okay. So this is very important. In other words, you do not take inverse trig functions of angles. You take inverse trig functions of numbers to get angles. You take trig functions of angles to get ratios. So, here's a triangle that you've been working with for probably 3 years. Do you know what this angle is? Actually, you probably don't, because they've never focused on it until now. In other words, you're taught to recognize that you have a 3, 4, 5 right triangle, or multiples. It could be 30, 40, 50, or it could be 6, 8, 10. Okay, but you're never really taught about that angle. Well, if I take inverse trig functions of ratios in order to get angles, what goes in the parentheses? Okay. Now, that is not an angle, or that is not something we can do manually. You have to get that from your calculator. So do you have your calculator in front of you? Get it. Always have it. Inverse sine of 3/5. And that will tell you what that angle is. Okay. You've either got your calculator in Radians, or you didn't properly apply the parentheses. Try taking the inverse sine of 0.6, which is the same as 3/5. Just do the inverse sine of 0.6. What do you get? It should be in degrees. For the moment, let's leave everything in degrees, and then we'll spend part of this session talking about the difference between degrees and radians. Aha, 36.86 is that angle. Who knew? This one's complementary to that, so this one has to be 53.14. So the inverse sine of 3/5 is this angle right there. How would I get this one up here? If I didn't know this one already, let's make this theta up there. Same 3, 4, 5 triangle. What inverse trig function would I use to figure out that angle? And I have a lot of choices. I can use inverse cosine, I can use inverse sine, I can use inverse tangent. They all should give me that angle. Pick one. Inverse sine of what? Four-fifths, right, because this is a different angle. So the sine is different. Sine is opposite over hypotenuse. So which calculator tell you that is? Okay. So that's how you do angles. That's how you figure out angles. And it only is going to work for the moment on right triangles. The moment you don't have a right triangle, everything changes. Okay? But it'll work on any right triangle. I don't know what that is. Can I still solve for theta? What is theta equal to? Tell me conceptually, not from your calculator, but tell me what the trig, the inverse, we need an inverse trig function for sure. Which one are we going to use? Aha, yeah, because we don't know. Cosine and sine both use that. So we could figure out what the hypotenuse is if we wanted to apply the Pythagorean theorem, but it's not necessary. We can use the inverse tangent. We do not need to know that hypotenuse. What goes in the argument? Make sure you can do that on your calculator in one step. And the key is just making sure you put a parenthesis, I think. I don't know. Go ahead and try. Yeah, it's a little tricky. That's why I wanted you to do it. That sounds right. So I'm going to trust that you did it properly. Tell me what the inverse cosine of root 3 over 2. Do that in your calculator. Let's just make sure you're doing it right. Aha, that is the cosine of 30 degrees, right? Because remember, the dimensions on this thing are these. So the cosine of 30 degrees would be root 3 over 2. Therefore, the inverse cosine of root 3 over 2 has to be 30 degrees. Okay? All right, so that's very straightforward. Now, from your previous statement, I gather that they have taught you about radians, correct? What's the conversion factor? To convert radians to degrees or to go the other way, degrees to radians. Let's say I'm converting 90 degrees. How do I convert that to radians? It's exactly 180 over pi or pi over 180, depending on which way you're going. Which one is it here? First of all, when you look at these conversion factors, there's the degrees, there's the radians, there's the radians. Okay? So, the one you choose is based on, you're trying to get rid of degrees, right? And turn it into radians. Which one do I use? The one on the left or the one on the right? Yeah. Pi radians over 180 degrees. Notice the degrees are going to go away. We're going to end up with pi over 2 radians. And that's the answer. When you're in radian mode, 90 degrees is pi over 2. Okay? So the way to memorize which one it is, 180 over pi or pi over 180, is what are you trying to get rid of and what are you trying to go to? In other words, if I had pi over 3 radians, what's the conversion factor? Which is pi's cancel, the radians cancel, you're left with the degrees. What is the answer? $60 degrees. Not 60 radians, 60 degrees. Most of your radian measurements will have a pi in it. Not always. Not when you get to a little bit more advanced trig. But at the beginning, you can tell if you have a radian measurement if there's a pi in it. Okay? Now, everything on this page, you want to be able to do it this way. You want to be able to take any, in other words, if I said, what is 79 degrees? How do you do that? You can do that in your calculator. That'll tell you how, yep, just put 79 times pi divided by 180. That will give you a number that is the radian measurement. Yeah, 1.37. Now, notice what pi over 2 is. Remember, pi is 3.14 approximately. So pi over 2 is about 1.55. That's a real number, okay? Now, typically, you don't use the units. Radians are a very, very peculiar alternative way of referring to angles. And I can't even explain why it's different. It is not like converting yards to meters or miles to kilometers. Those are all just different measurements of the same unit. Radians and degrees aren't quite like that. You can definitely convert any degree measurement into radians, and you can convert any radian measurement into degrees using one of these two things here. But it's just strange enough that you don't say radians. You say an angle is pi over 2. You don't say pi over 2 radians. If I say an angle is 67 degrees, I do say degrees. So if they're not giving you degrees, it means it's in radians, even if there's no pi in it. Usually there'll be a pi in it. And that will mean, okay, you're talking about radians. Okay? Now, I want to help you because I can pay very close attention to this. These are the important ones. These are the ones that you need to memorize almost. Pi over 2 is 90 degrees. pi over 3 is 60 degrees. Notice the pattern? Tell me what the pattern is. 2 times 90 is 180. 3 times 60 is 180. What's the next answer? 4 times 45 is 180. What's the next answer? What's pi over 6? Notice how much easier it is to memorize this. If you're dealing with first quadrant angles, which all of those are, is all you have to do is this simple little method of converting to degrees. Just make sure your denominator multiplies the degrees and comes up with 180. So, once you get this down, and you get it down well so that you know those 4 relationships right there, tell me what 2 pi over 3 is. That'll get a little more complicated. Now, normally people would just immediately go to that complicated conversion factor, 180 over pi, and solve it. But if you know pi over 3 is 60, what's 2 pi over 3? Without doing it the hard way. It's twice as much. Isn't 2 pi over 3 2 times as much as pi over 3? So what's the answer got to be? What is 3 pi over 4? Very good. What's 5 pi over 6? Don't need your 150. Don't need your calculator. It's 5 times 30. It's not 6 times 30. In other words, pi over 6 is 30 degrees. We know that. So 5 pi over 6 is 5 times 30. So that's 150 degrees. Now, which method do you like better for converting radians to degrees? This one, yes, much easier. Even if you had something like 7, these angles give people fits. Because, you got to multiply that by 180 over pi. That's complicated. But what if you just have to multiply 7 times 30? Boom. Easy as pie. No pun intended. So to me, this, and usually what you're going to be confronted with is converting radians to degrees. In other words, they're going to give you problems like this. Now, you can do this 2 ways. You can teach your brain to think in radians. That's hard to do at the beginning. You might be able to pull that off by the end of the semester, but at the beginning, what most people do is convert this to degrees. So that's equal to the sine of what in degrees? What's pi over 4? Yep. So it's 3 pi over 4. Yeah. And that's probably the way you'll do it. Now put that in your calculator. Make sure you're in degree mode. Does your calculator tell you whether you're in degree mode or radian mode, or is it something you're constantly not aware which mode you're in? Okay, good. Thank goodness. Calculators finally do that. Because for a long time they didn't. In fact, I've got a TI Inspire that doesn't tell you, and you have to just kind of, it's not even easy to change between radian and degree mode. But, so what's the answer for the sine of 135? What is it? 0.7. You know what that actually is? Square root of 2 over 2. No? Remember, we take trig functions of angles to get ratios. There's the ratio. How do I get that? Well, that is a 45-degree angle, right? In other words, I start off by doing this. Sine of 135 degrees is the same as, what is its first quadrant angle? 45, right? We do 180 minus theta. And what is the sine of 45? That's 1 root 2. What's the sine of 45? Just do it from the triangle. Yeah, don't do it from your calculator. Do it from looking at this triangle. Opposite over hypotenuse. Yeah, but notice that that's hard to figure out what that is. So let's rationalize it. Same thing as root 2 over 2. And root 2 is about 1.41. Divided by 2, that's where you get the 0.7. But it's important to realize that your calculator is rounding it off, always. Your calculator doesn't have the ability, I don't think it does, to give you root 2 over 2 or 1 over root 2, either of which is satisfactory as an exact answer. 0.7 is rounded off. It's actually probably 0.707, if my memory serves me correct. But it's still rounded off. You could carry it out to 12 decimal places and it would still be rounded off. So they're actually more interested in you knowing that it's either 1 over root 2 or root 2 over 2. They're both the same number. It kind of depends on your trig teacher as to, these days I'm finding more and more trig teachers that they do not want you to rationalize it. Just leave it unrationalized. In other words, 1 over root 2 is a perfectly acceptable answer. Whereas it wasn't a year ago in your math class. They had you rationalize everything. But trig is kind of unique, where you end up with an awful lot of these fractions where you have an irrational denominator. Okay? And it's not worth the trouble to rationalize it, because there's a whole other group of trig function you haven't been exposed to yet. And that's cotangent, secant, and cosecant. Have they told you about those yet? Okay. Those are the reciprocal. So if I said to you the sine of 45 degrees is 1 over root 2, what is the cosecant of 45 degrees, which is the reciprocal? Yeah, notice that I don't want it rationalized. If I would have rationalized this as square root of 2 over 2, now when I take the reciprocal, I got 2 over root 2, and then I still have an irrational denominator. And that goes on all the time in trig, because the difference between your 3 primary trig functions and what I call your 3 secondary trig functions is they're just reciprocals of one another. So you're constantly flipping numerator and denominator. And that's why teachers don't insist that you go to all this trouble to rationalize everything. Because sometimes it's self-defeating. You rationalize something and then they want to know what the cosecant is, and you flip it and then you got to rationalize it all over again. So it's not worth rationalizing stuff. After all, this is a real number. It happens to be the same as that. And this is more proper convention because it has a rational denominator. This does not because it has an irrational denominator. But in trig, don't distinguish between the two. Just unless your teacher tells you to rationalize everything, you shouldn't. Okay? All right. So we got radians to degrees Tell me how many radians that is. No. Just think that the 30 times the denominator has to equal 180. When the only thing in the numerator is 1 pi, then the denominator's got to be 6. Those two things multiply always to 180. So 45 degrees is what? Pi over what? 4. Those two things multiply to 180. 90 degrees is what? Try to memorize those. All of them in the first quadrant memorize. And you'll save yourself a lot of time and effort in converting these things. If you know what 30, 45, and 60 are, then you can figure out the hard ones, like 5 pi over 4. What's 5 pi over 4? Yeah, if you know what pi over 4 is, it's 5 times that amount. Yeah. See how much easier it is to do. You don't need a calculator. Just multiplying whole numbers by numbers that are easy to multiply by. However, don't ever forget that primary, because sometimes they're going to say, what is this? And then you can't use that rule. But most of the angles you're going to be dealing with are going to be multiples of 30, 45, 30 or 45. It will be. In other words, if I wanted to convert 29 degrees, then I'm going to have to use the pi over 180. Knowing I've got to get rid of the degrees. So that becomes 29 pi over 180, and there's your answer. Can't be reduced. Okay? So occasionally you do have to use that full conversion factor when you're doing an odd angle. But for the first couple of months, they'll probably keep you on 30-degree angles, 60-degree angles, 120-degree angles, 180-degree angles, things like that. Everything will be a multiple of 30 or 45. So what haven't we covered tonight that you've been covering? Yeah, 3 minutes. Okay. Okay. You haven't been learning a lot? Okay. Well, that's fine. You will. It'll come fast and furious way too soon. So it's good that you're still reviewing it. I got a feeling you're going to do pretty good, Brandon, at Trig. And here's why. Well, here's why. Because you don't actually have to have a mastery of the multiplication and division tables, that you still have a weakness in. In other words, you still rely on that calculator. And Trig is, you're memorizing a whole new set of things. You still have to be able to multiply 3 times 50, or 4 times 45, things like that. And that's okay if you use your calculator for that. But the main thing you're memorizing is new stuff. And you're older now. You have the ability to memorize this new stuff. When they taught you your times tables, you weren't paying attention. And so you're constantly catching up on those. And the biggest favor you could do yourself would be to just spend time drilling on those times tables. I believe it more than I believe almost anything. That's the best thing you could do for yourself. But it's not going to, it held you back in algebra. Because you can't really do algebra 2 without being good at your times tables and adding and subtracting positive and negative numbers and all of that. But with Trig, it's not that way. Trig, they're kind of giving you a whole new thing to memorize. It's like they're teaching you French instead of English. It's like a different language. And so you get to start from scratch and just try to memorize this stuff. There is definitely a lot of memorization in Trig to do, a whole lot. But I can help you with methods of memorizing. It's like memorizing this conversion from degrees to radians. There's the hard way to do it, and there's an easy way to do it. And it's kind of like that with all these trig identities. You're going to end up with like 25 trig identities that they're going to want you to memorize. One such identity is this. That's what cosecant is. And if that is true, then this has to be true. In other words, they are reciprocals of one another. And that's something you just have to memorize. But there are even tricks I can teach you for memorizing these identities. But it's a whole new ball game. You get basically start from scratch. You can do well on this. Just have to apply yourself to memorizing this stuff. Okay? We're just doing a half hour tonight, right? Okay. I will let you go then. You're welcome. Talk to you next time, Brenda. Bye-bye.